In the previous lesson, we learned about the SI unit. And the SI unit is basically just the name of the system of unit that our scientists use today. We have the SI, that's because it's named after a French name, Système International, where in English we would have International System. Now the SI system is based on the older system of unit called the metric system. And we also learn about the structure of a measurement. That is, a measurement will always include a number, a unit, and in chemistry we have a chemical, or the substance that's being measured. Now each of the part of the measurement will add values to the entire measurement. That is, if we change any of the part, it would change the values of the whole entire measurement. In this video, we are going to look at the part unit and how a unit of a chemical has a structure of prefix plus the root. And we learned that the root are basically the base unit of the SI except for kilogram, where kilogram would have the gram as your root. So this lesson is about measurement with prefixes. And here we have an illustration to relate the A base unit of an SI. This is the building block of all the SI unit. And this building block will combine each other to make endless number of derived units, such as a unit for energy in joule, or a unit for force in Newton, or a unit for volume in meter cube, or a unit for density, grams over milliliter. All of these are derived units that originate from the base unit. Now let's go back to talk about our prefixes. Now let's talk about the prefixes. First of all, if we look at this table, we have many prefixes. And what we realize is that each prefix represents a specific number. But all the number has something in common. That is, they all have the base of 10. So we can say that each prefix represents a number with the base of 10, but the number of exponents are different. So the number of exponents is defined by the prefix name. For instance, mega is 10 to the 6, kilo 10 to the 3, milli 10 to the negative 3, milli 10 to the 3, but for the base unit is 10 to the 0, because anything to the 0 is equal to 1. That is, when we have a unit without any prefix, we know it is 10 to the 0 of that unit, or just that unit itself. So let's look at some example. In this example, list the following measurement from largest to smallest. Notice how we have 100 nanometer, 12.7 megameter, 2.0 micrometer. Before we can determine the values of all the measurements, we have to compare them to a specific unit. In this case, is their root. Going back to the base unit again, except for kilogram. So we have 100 nanometer. Look at the nano. The nano is 10 to the negative 9. So basically, we have 100 times 10 to the negative 9. The beautiful thing about time 10 right here is that on our calculator, we have a button that represents time 10. And that button is EXP or EEE. In this case, I have this calculator here. You can see that button, EXP right there. That represents time 10 to the power of something. In this case, that something is 9. So let me show you how is that going to work. To get the values of this, I would take 100 EXP. Do you see the E right there? Negative 9. And that gave me the values of this measurement. As you can see, the number 100 gives us the values of 100. But when we interpret with the unit, in this case the prefix nano, which is representing 10 to the negative 9, it makes the entire measurement into a very small number, and this number is the length of a flu virus. Let's try another example. Here I have a smaller number, 12.7, and what does the big M stand for? That is mega times 10 to the 6th power. So again, this time 10 is represented by the EXP button on a calculator. Let's plug this into a calculator. 12.7 EXP again. And also the most important thing about this EXP is that when we use the EXP, this now becomes a single number. If you press multiply time 10 to the 6th power, it becomes two separate numbers. So that's why it's very important to use EXP instead of typing 10 to the power something. And then we have our answer. Notice how we have a very large number, even though we start a very small number. We have megameter. Because of the prefix mega, it changed the values of the whole entire measurement. And this distance is actually the diameter of our planet Earth. Let's try another one. We have 2.0 micrometer. And micro is represented by the letter U right there. So micro is time 10 to the -6. Notice how we have a 2, a very common number. But by adding the prefix micro, now we have 2 times 10 to the -6. And again, this is represented by EXP button on a calculator. It's important to use this EXP because it allows us to tell the calculator that this is a single number rather than two individual numbers. So we type in our number 2.0 EXP -6, and we have this very small number. And notice again, we have 2.0, a normal number. But by adding the values of the unit, in this case has a prefix micro, it makes this whole entire measurement extremely small. And this is the length of an E. coli bacteria that we get sick when we eat raw food or raw meat. So let's go back to the problem. List from largest to smallest. Of course, the largest one would be 12.7 megameter, followed by 2.0 micrometer, and lastly, the smallest one is 100 nanometer. As you can see, the number in front of a measurement, 12.7, 2.0, 100, those numbers only tell us a little bit about the values of the measurement. But most importantly, we have to look at the unit in the measurement. As you can see, the values of a measurement is not based on just the number, but it's based on the number and the unit of that measurement. Let's try a few more examples. List the following measurements from largest to smallest. Here I have 0.0003 megaliter. And again, mega represents time 10 to the 6th power. So we're using our calculator. We plug it in. Remember to use the EXP button or the EE button on your calculator to represent that this is a single number. So 0.003 EXP to the 6th. And what we have here is 3,000 liter. Then over here we have 2,000 milliliter. Notice how this number is extremely bigger than that number, right? But let's plug this in. M represents the milli part. That is time 10 to the -3. So let's plug into our calculator. 2,000, a very large number compared to 0.003. But if we combine it with the unit, EXP minus 3, this 2,000 milliliter turned out to be just 2 liters. And this is how much water you are required to drink every single day. 2 liters of water to keep you healthy. Then we have a very large number. This number actually 20 million. So in this case, 20 million microliter. And again, what is the micro part? The micro part is time 10 to the -6. And again, we plug this into the calculator. 20 million EXP to the -6. And that give us 20 liter. And 20 liter, if we look into water, this is how much water you use every single time you flush your toilet. Now, if we rank this from largest to smallest, of course, we have this small number right there, 0.0003, but the unit microliter make it into a very large number, so this would be the largest, followed by this number. So 0.0003 microliter, followed by 20 million microliter, and lastly 2,000 milliliter. As you can see it again, Don't judge a measurement based on just a number, but look at the unit itself. And later on, we're going to talk about the chemical.